Hey everybody, Rusty Morgan here with Propspeed USA. I wanted to talk a little bit about the relationship between corrosion and Propspeed. Now, corrosion in the marine world is kind of this misunderstood thing, but it happens with literally every boat out there, and there's a number of ways which you can protect your boat and protect your underwater assets from corrosion. Now, I am not a corrosion expert. I'm the Propspeed sales rep. However, we have a lot of really high caliber experts out in the field, and they've relayed a lot of information to me, and they've distilled that down into some really kind of easy to understand ways. And I'm going to try to relay that to you guys today. So if you have any further questions or we've gotten anything wrong, make sure to contact us. We're available on the web, propspeed.com. You can email me, you can call me, and we will connect you with the right person that can make sure that your question gets answered. So today, what I'd like to talk about was how Propspeed's corrosion protection can really benefit everybody as a user in terms of making sure that they're protected from corrosion. So Propspeed was initially developed to solve the problem of fouling on propellers, right? So since then, we've found out that it really has a lot of benefits, and Propspeed does much more than that. So the big question, what is Propspeed? I sure would like to know. But Propspeed's a two-part coating made up of an etching primer and a silicone-based top coat. Now, you may already know a lot of information about Propspeed, which is why you're watching this video right now. But I'm going to run over the process for those of you that haven't. And again, if you have any other questions, please get in touch with us on the web, www.propspeed.com. You can email me, rusty@propspeed.com. My phone number is on the internet. Thank you for that. But it's there. Call me if you have any questions. So basically, we have Propspeed is a foul release coating, and it's been developed to protect underwater metal surfaces from fouling. It's a multi-season product. It's trusted globally, and it's a two-part coating made up of an etching primer and a clear silicone top coat. So with that in mind, let's go over the process. We have this process, and we've developed it over time to ensure that maximum performance of the coating occurs. And it really consists of 4 simple steps: initial clean, metal conditioning, etching primer, and finally the clear coat. So let's talk a little bit about how these steps work and how they all work together. So first of all, preparation. Before you start the application process, the metal has to be abraded with an 80 grit profile, to an 80 grit profile, before Propspeed can be applied. This is what we in the industry call the tooth, right? We want to have these scratches in the surface of the prop so that the paint has something to stick to. You can do this by hand. You can do this with a DA or dual action sander, or an air sander, or even a hand-powered oscillating sander. There are some areas that are going to be difficult to reach, especially down in the hub area or little tight areas. With that, take your 80 grit sandpaper and just use it by hand. Make sure to kind of crisscross, just like you would with sanding any surface in preparation for paint. Sanding really is paramount in this application process for 2 reasons. Number 1, thoroughly cleaning the surface of any residual coatings, if you had any old anti-foul or any grease or that sort of thing. And again, creating that profile for a mechanical bond. So step 1 is the initial clean. So a coating is only as good as the surface that you apply it to. And the first step is applying the prop clean. This is a solution which dissolves organic materials such as grease and fingerprint residue. It's a solvent, and essentially you want to get everything that is not just metal off of that surface. I always tell the guys in the yard, if you just came back from your lunch and you were eating a giant burrito or a slice of pizza and you've got your greasy fingers, the first thing you want to do is touch that beautifully polished bare metal prop. Don't do it. You're going to get a fingerprint on there. It's going to cause a failure. All right. So that prop clean step is extremely important. So moving on to step 2 is the metal conditioning. Now, metal conditioning, we use our solution, our prop prep solution, which is essentially a acid pre-etch. It's essential to the chemical preparation of the metal substrate to be coated with Propspeed. Prop prep contains the ingredients that react with the metal, and they create a porous surface layer. This porous layer is key to ensuring proper penetration and the completion of the self-etching reaction of the primer to the metal substrate. let's say that in English, what you want to do is you want to create a nice abraded surface, right? You want to get down into those pores with the chemical etch, and you want to provide, again, a great mechanical surface for that etch primer to adhere to. So step 3, onto our etching primer. This is the base layer. This is the base of what is going to have your application be successful. And Propspeed's etching primer is unique in the way that it forms a chemical and physical bond with the metal substrate. The secret to Propspeed's superior protection against corrosion is right here in the etching primer. It's what gives Propspeed the iconic yellow color that you see on props, shafts, struts, and rudders all over the world. And it contains an anti-corrosive additive, which is what makes Propspeed the best corrosion protection on the market. When the etching primer reacts with the metal substrate, it forms a bond that creates little tiny gas bubbles. These gas bubbles leave capillaries, think tiny thin tubes, through the etching primer. And this makes the perfect base for the clear coat. So step 4, the top layer. After applying the etching primer, the Propspeed clear coat is then applied. How does the clear coat work? Well, when the clear coat is applied, it soaks into those capillary holes. It's a little bit like this. I'm going to use my fingers a lot for this demonstration, so please bear with me. All right, so you've created scratches and abrasions in the surface of the propeller. You've added the prop prep solution that creates further capillaries. You've added the etching primer, which has these other capillaries in it. Now over the top of it, you're going to put that clear coat. That clear coat is going to mechanically bond in with both the etching primer and the metal substrate to create a really, really awesome bond. All right, this process is why we have such a narrow application window in our directions. As you probably know, if you've used Propspeed, you have about 5 minutes between when you put on that etching primer and you put on that clear coat. When you wait longer than 5 minutes, those capillaries close up, and then you end up with this, right? And you end up with just the silicone top coat, which is very slippery, sitting on top of the etching primer. And that's when you get failures. So it's really important that you adhere to our directions because you really want to get that super strong mechanical bond. So, more than a propeller coating. Combined, the Propspeed system is more than a propeller coating, and Propspeed can be used to protect all of your underwater metals. We talk a lot about propellers because, well, without getting too deep into the weeds, the prop is the business end of your boat, right? If you get growth or fouling on your propeller, you can see a pretty significant reduction in power at the shaft, which turns into more speed for you, the boat owner or the boat operator. All right, you can also use this system on shafts, rudders, struts, trim tabs, swim steps, platforms, assemblies, underwater lights, transducers, you name it, the list goes on forever. We wanted to talk about corrosion because corrosion affects every single one of these components. So let's talk about it. Corrosion and cathodic protection. So we've done a quick crash course on how you apply Propspeed. I assume you got it down pat. Again, call me if you don't. But what I really wanted to talk to you about today was corrosion. Now we've partnered with the team at Marine Protection Systems to help demystify corrosion and cathodic protection. And by understanding this, you can then learn how to extend the life of your coatings through using the right systems. As you can imagine, this is an extensive topic, so we'll just be focusing on the basics of understanding corrosion, cathodic protection, and how it relates to these coatings. So, for starters, what is corrosion? A quick Google search will get you onto Wikipedia, where they'll define corrosion as the gradual destruction of materials, usually metal, by chemical and or electrochemical reaction with their environment. What in the world does that mean? Well, it means that essentially we're creating a battery, and one component of that battery is your propeller, and the other component of that battery, the electrolyte, is the salt water that you've just dropped it into. Okay? If you want to prevent, identify, or fix a corrosion issue, it's important to first understand the different types of corrosion, however, that a vessel may be susceptible to. So I'll give you a quick overview of the 5 most prevalent forms. I've listed them right here: galvanic, straight current, environmental, oxidative, and crevice corrosion. We'll get into each one of these. So here we go. Galvanic corrosion first. Now this is one of the things that we hear about the most. All metals have what's called an electrical potential when they are submerged in salt water, just that battery example that I was giving you a second ago. Galvanic corrosion occurs when two dissimilar metals, meaning aluminum and stainless steel, or bronze and stainless steel, or bronze and aluminum, are immersed in water and they're electrically connected. Now, your boat is connected to its batteries or its shore power, or maybe your neighbor's boat, or maybe your contractor left an extension cord hanging in the water. Who knows? But when these two things are electrically connected, a battery is formed. Do you remember that experiment you did when you stuck the copper in the aluminum things in the potato and you got it to light a light up back in 3rd grade? Well, that's the battery we're talking about. Okay, so this will result in one of your metals becoming the anode, which will give up its metal ions, and the other is called a cathode, which will receive or attract the metal ions. So thus the term sacrificial anode. The more active the metal will sacrifice itself to protect the more noble metal. It's very chivalristic, but it's true. So, for example, if you have a bronze propeller on a stainless steel shaft, the bronze propeller will sacrifice to protect the stainless steel. This is because the bronze is the more active metal and the stainless steel is the more noble metal. Preventing this form of corrosion is essentially the job of your sacrificial anodes, or your zincs in common terms. By introducing a more active metal to the galvanic cell, you thereby determine the sacrificial anode, which will stop your precious metals from corroding. So that means that you put those zincs on there so that rather than your bronze propeller fizzing off and disappearing into oblivion, your anode disappears as well, which is why it's very important to have your diver replace them frequently. So let's move on to straight current and electrolysis, or electrolytics. Electrolytic or straight current corrosion is corrosion activity induced by the presence of stray electrical current. The source and type of electrical current will usually determine the type of damage that we see. Typically DC power, that's the type of power coming out of your 12 volt or 24 volt batteries, is the culprit for aggressive corrosion, causing rapid anode dissipation and or devastating corrosion effects, usually in short periods of time. Common culprits for this are insulation failure or wiring of one of the appliances on the vessel, earth leakage from a device such as a bilge pump or an alternator, or externally through common shore power connections where galvanic isolation is not installed or operating correctly. Good maintenance and high electrical fitness are really important to prevent this action, however, not always foreseeable. So it's good to find an expert who can guide you and make sure they can correctly diagnose and fix this problem before it becomes a heartbreaking episode, i.e., you start your boat and one of your propeller blades flies off. We've seen it before, and that's a problem that nobody really wants to have. So let's move on to environmental corrosion. So corrosion can be aggravated or caused by multiple environmental factors, such as water temperature, humidity, exposure to oxygen and salinity, that's how salty the water is. Understanding these different factors and how they may be contributing to your corrosion problem will help you take the appropriate measures to stop against it. We also have oxidative corrosion, known as surface corrosion. And this occurs when a bare metallic surface reacts with oxygen, causing a local reaction of corrosion on the surface. Think rusting. Iron oxide is the most common one that you see, right? If you take a mild steel fence and you don't put some, anti-corrosion spray paint or other, hot galvanizing spray or something like that over the top of it, it will turn rusty usually in a day or two, right? That is your oxidative corrosion. Galvanic and straight current corrosion can also worsen this reaction, and metals such as bronze and aluminum are particularly vulnerable. The best protection against oxidative corrosion is through the use of coatings. So you're going to isolate the substrates from oxygen. That means that you're going to put a barrier in between that mild steel or your bronze propeller and the oxygen that really wants to not attack it, but kind of exacerbate those corrosive properties. So oxidative corrosion is one of the most common ones that we see out of the water. It's less so in the water, but it can absolutely happen because oxygen is definitely in the water. How do you think fish breathe? All right, so moving on to crevice corrosion. Crevice corrosion is a very specific form of corrosion, and it corrodes stainless steel in particular. Stainless steel doesn't corrode like regular metal because it's got a tightly adhered layer of chromous oxide on the surface of the metal. That's why stainless is so resistant to rusting or oxidizing. But this coating can only form in the presence of oxygen. So a small crevice in the stainless steel that does allow exposure to oxygen. Well, sorry. Let me walk that back. A small crevice in the metal that does not allow exposure to oxygen, but does allow moisture to enter, meaning that you have a small crevice where water can get into your shaft, for example, can result in a breakdown of the protective coating that stainless steel has and allow it to corrode. This is commonly seen between pipe threads, stern tubes, and under bolt heads. You've seen it before when you see small little rust spots on your stainless steel. It can be very damaging, and it can also be really hard to spot. So now that you know the different types of corrosion, it's important to correctly identify them so that you can fix it. So here are some types of corrosion that are specific to areas we focus on. Number one, de-zincification is when bronze has lost contact with an anode or a bonding system is actively corroding. As you can see, that's when you notice that your propeller has turned a little bit pink in some spots and maybe feels a little bit rougher than it used to. Okay, paint blasting is commonly seen on stainless steel trim tabs or swim platforms. This is caused by overprotection, meaning you have too many zincs. It can be fixed by selecting the right anodes combined with the right coatings. Number three, zinc passivization, that's a mouthful. Zinc passivization is when a crust layer is built up on the zinc anode. This is caused by changes in the current on the anode. Ensuring the right anode is installed will prevent this, and it's why it's also very important that the divers clean off the surface of the anode when they're down below. Finally, electrolysis. And this is caused when either stray currents on board or faulty wiring or from a marina stray current. If you install an electrolysis blocker first, then you can work on proper cathodic protection. So what is cathodic protection? What does this even mean? Cathodic protection is used to control the galvanic corrosion of a metal by making it the cathode, while utilizing an anode to sacrifice the ions. So sacrificial anodes are used as a form of cathodic protection, right? So we're going to use those zincs to fizz off their metal so that your stainless steel doesn't. When an anode corrodes due to having a more negative potential, in other words, a negative voltage, it's got a more negative voltage than the metal that's being protected, the cathode. So it's important to note that there are several factors that affect cathodic protection. So, salinity and conductivity. The corrosion rate in seawater is up to 10 times faster than it is in freshwater. Current requirements increase with salinity. That means that seawater is low in resistance, right? That salt in the water helps electricity travel through it a little bit easier. So freshwater is a less conductive electrolyte, and it is high in resistance. So it's a poor conductor and requires high driving potentials, which means you need a ton of voltage to get all that electricity in freshwater from your source to your cathode. Magnesium anodes are widely used in freshwater applications for exactly this reason. Water flow rate. The increased velocity of water will increase a vessel's cathodic protection requirements. Well, the water flow rate can be affected in high volume traffic areas like ports or busy recreational areas, or in a place where you have a huge tide swing. Think France, England, or the northwest of the US, where you might have 6 or 10 feet of tide. When that water is moving all the time, it's going to increase that need for cathodic protection. Acidity, the pH of water affects the rate of corrosion. So when pH levels go down, there's an increase in the rate of corrosion. Protective coatings, such as paints and propeller applications, can improve the cathodic protection of a vessel. As protective coatings deteriorate, there is an increase in the rate of corrosion for the exposed metal. Infrastructure. The construction materials of jetties and walkways can impact the rate of corrosion in a marina environment. This depends on the composition of the materials used and the surface area of the infrastructure in the water compared to the relative voltage generated to other submerged metallic fittings. What does that really mean? It just means that there's a major difference if you are in a marina who has steel pilings or cement seawalls, or maybe natural riprap as a blocker for marina versus driven steel pilings in. When you get those steel pilings in, you're going to get much higher electrical potential. Proximity to other vessels. This is what we hear all the time from boat owners. They say, oh, it's my neighbor's boat causing it. And you know what? It may be. So the proximity of other metals in the water affects the distance and often the strength of ion flow between the anode and cathode. Consider a scenario of the relationship between two vessels in a yacht club that are neighboring slips. In contrast to the rate of corrosion between identical vessels on swing moorings 200 feet away, right? So when they're really close, you have a high potential of transfer of ions or transfer of electrical potential. When you're really far away, it's way less of a issue. And finally, connection to shore power. So when a boat is connected to your shore power, it's also connected to that ground on your shore power, hopefully. And then finally through the marina and then all the way back to the earth. The connection between vessels via the earthing grounding connector provides for a galvanic corrosion between dissimilar metals on the vessel's connection. So you can, whether a marina is wired poorly or the ground resistance is high, you can end up with a higher incidence of cathodic corrosion because of that. By understanding these factors, we can develop a cathodic protection system that's best suited for every vessel. So, how can we minimize corrosion? How do we get rid of this stuff? The main methods include anodes, coating, good maintenance, shore power isolation, galvanic isolators. Firstly, use of the sacrificial anodes, use of your zincs are going to control the risk of a galvanic corrosion. Understanding what metals you are protecting, whether it's bronze or steel or aluminum, will give rise to the correct anode to use. Contact a local expert if you have any questions about that. But commonly it's zinc in salt water and aluminum or magnesium in fresh water. The incorrect anode can result in either underprotection, known as galvanic corrosion, or overprotection, which will result in poor coating performance and potentially coating failure. This is a process called cathodic disbondment. The use of a paint or coating to protect the metal by essentially isolating the metal from oxygen in the electrolyte. Quality underwater metal coatings like Propspeed reduce this risk of corrosion. The best form of protection is implementing a system to enhance the performance and efficiency of the products. Sacrificial anodes are just the start. Combining the right anode type with the right coatings will not only provide superior corrosion protection, it will also extend the life of both the anodes and the coatings. So, Propspeed, corrosion, and anodes. What is the link here? What are we talking about? Propspeed reduces the risk of corrosion by electrically isolating the metal as well as limiting the exchanges between the ions and the gases contained in the water and the metal. In short, if a reaction can't occur, there will be no corrosion. Yay, that's what we want. So not only are our customers seeing an increase in vessel speed, less RPMs, more fuel savings, all that stuff, they're also experiencing protection from stray current damage, resulting in longer anode life. It's been observed by our customers that by using Propspeed on their running gear, they've seen a dramatic reduction in corrosion to their underwater metals. And their sacrificial anodes are lasting longer. So by isolating the metal substrate, Propspeed is going to reduce the wetted metal surface on a vessel. And this means that sacrificial anodes do not need to work as hard to protect the vessel from corrosion. By decreasing the amount of metal exposed to the electrical currents, the anode will work more efficiently and last longer. The image shown here shows Propspeed still looking in mint condition after 22 months of service. The Propspeed hadn't even been pressure washed yet, which is why you see some light fouling on the shafts. This was easily removed just by wiping it off by hand. Having the right cathodic protection and setup will get you these results. So, how does Propspeed protect against corrosion? Well, it actively protects in two ways. The first is by providing a dielectric barrier between the metal and the external environment, right? Just like we were talking before about separating that metal substrate from the oxygen. That's what Propspeed's going to do. The second way it protects is through the use of an anti-corrosive agent in the etching primer. So not only does the primer protect the metal that it's directly in contact with, it also offers protection to nearby areas due to its ionic size matching. This is particularly effective against stray currents from other boats. Think your grubby neighbor in the slip next to you, or electrically active materials in the vicinity. Propspeed does not protect against electrolysis where the origin is on the boat itself. This will need to be addressed by a marine electronics professional, and we can see this sometimes. So be aware that there is a challenge there in that. So let's see, these images right here show the results of an accelerated electrolysis test that was done in a corrosion testing tank. This test reproduces the electrochemical conditions of a boat that's immersed in the ocean. And these three coatings were all subjected to destructive testing for 2 hours in each tank. That's 2 hours, all right? Each was applied following the specified instructions as per the manufacturer. They were cross-scratched in that X formation that you see to form a break in the coating, to break down the coating in a very specific area to test the resistance against corrosion. The gold Propspeed coating doesn't show any blistering or delamination. The damage caused by the cross-scratch was isolated and the coating remained in perfect condition throughout the 2-hour test. Unfortunately, the other two competitor products did not have the same results. Both of these coatings delaminated within 2 hours. If these coatings were on a spinning propeller, they would look a lot worse for the wear than they do in these pictures here. So in this example, Propspeed outperformed because it's a system that provides those two layers of protection that we've just been talking about, the etching primer and the clear coat, and they're working together to deliver great results. And there's something that's really key here. If you notice in these pictures, you can see clearly the shiny metal underneath with none of the tie coats involved in these other products, right? That means that all of that paint has actually blasted off of the surface of the propeller. Again, as I said, imagine if this was your boat running at 2,700 RPMs. You are not going to see very much of that paint left. So let's talk a little bit about comparison. So we created a video to show the direct comparison between an unprotected propeller blade and a Propspeed coated propeller blade. Using our corrosion testing tank, we can control the amount of current running through the metal. The higher the voltage, the faster the metal or coating will degrade. You see here that the bare propeller blade on the left-hand side is literally fizzing away. The gas bubbles that are being released are from the chemical reaction caused by the current leaving the metal. All right, that's the Propspeed coated blade on the right shows very little reaction at all. This visually shows you how Propspeed can electrically isolate the metal. And I think this is really interesting because personally, I have actually gone into marinas and I've seen this happening on the zincs at the back of the boat, right? So you can actually see some of this occurring in real life if you know where to look. This is something that really can affect negatively the performance of your vessel. It can destroy the metals that are on your boat, and it can really cause problems for a lot of things. So have a look here, right? Now we're looking at the Propspeed. We've got a couple of bubbles, but it is far, far less than anything that's happening over on the other propeller. It's really indicative of how important it is that you have an active protection system on your boat and a really good high quality coating like Propspeed. So thank you. Again, I'm Rusty Morgan. I'm the West Coast sales rep for Propspeed USA. I live out in the Pacific Northwest. We love to chat with you guys. So if you have any questions on corrosion, and I'm sure you do, give us a call. Again, my cell phone number is literally on our website. Don't call me at 3 o'clock in the morning. I'll probably get a little bit annoyed at that, but I would love to hear email questions. You can go to our website, www.propspeed.com, and send questions via email or call or text even to one of our experts. And if we don't know the answer, we will put you in touch with somebody that does. Thank you so much for your time today. We're really excited to share this information with you, and we feel that the better educated the market can be, the better decisions people can make when it comes down to the products that they want to put on their boats. So again, Rusty from Propspeed, thank you for your time. I hope you're enjoying this presentation and this IBEX show.